My name is Solomon Afokogene Arumada. I am working on a PhD project titled Cost Estimation of CO2 Capture Processes. This is a PhD program in Process, Energy, and Automation Engineering at the University of South Eastern Norway. This project is supervised by Professor Lars Erik A. at USN, that is University of South Eastern Norway, and co-supervised by Associate Professor Frederick Norma at Chalmers University of Technology in Sweden. Nils Henrik Idrup also co-supervised this project, and he works at Sintef Tech and USN. Therefore, the external collaborators in these projects are Chalmers University of Technology in Sweden and Sintef Tech in Norway. The main objective of this project is to develop our existing cost estimation method, which is called Enhanced Detailed Factor Methods, that is EDF methods. And we are to apply it to study different CO2 capture processes and especially industrial concepts that we're going to study in this project, and also on different conditions in the energy markets, especially unit price variation in unit price of energy. The specific objectives are to establish a robust method for cost estimation of energy systems in general, but in particular, CO2 capture. And we are to establish tools for economic optimization of CO2 capture processes. This is key in this particular project because at USN, we are very particular about cost optimization of any chemical process that we study. Then we also develop links between process simulation tools and cost estimation tools for quick and easy estimation of new processes. This, we understand that different research is going on all over the world now, and as new solutions and especially cost reduction concept begin to emerge, then we need to cost estimate them to assess how much cost reduction can be achieved, or if they are not cost effective, then we also need to cost optimize them as they continue to emerge. Then also we develop links to different conditions in energy markets. For example, varying energy prices, as I mentioned earlier. Then the summary of the work done so far. We have developed we have developed a cost estimation tool, which we refer to as IDF scheme or IDF tool. The IDF means iterative detailed factor scheme. And this particular scheme or tool has been able to help us to drastically reduce the time required for iterative simulations, for sizing of equipment, and for cost estimation using our method, which is the ADF method. Then also, this particular scheme is capable of giving relatively fast estimates of capital cost, that is capital cost estimates or investments and operating costs. Yet the scheme or the tool is very simple to use, and it is able to give such estimates relatively fast when there is variation in different parameters. We have also linked the software, that is the ASPER in this particular case, with our cost estimation tools, such that the cost estimation results are obtained automatically, that is automatically, completely automatic, or in some situation partially automatic, immediately after a process simulation has converged, when it has converged. And this is just to show how we develop our process flow diagram in Aspen HYSYS simulation software. You can see the flue gas from the industry that normally comes at a temperature higher than what is required in the absorption column, and the solvent which is ME in this, the lean solvent, which is ME in this particular situation, we flow down and absorbs countercurrently and absorb the CO2 from the flue gas, which flue gas, letting clean gas to go from to exit the absorption column, while the rich CO2 rich solvent can flow to the stripping column, that is the dissolver, for the CO2 to be stripped off and it will be delivered, or it will go into the incorporation section where it can be pumped out for example, enhanced oil recovery, that is EOR. Thank you for your attention. You can contact me at saromada@gmail.com or at solomon.a.aromada@usn.no.